Okay, so today's the last lecture today, and today's topic is about AI alignment and safety and the future. But we also have to cover some of the topic from the last week. So I just want to start from the remaining slides from the last week's slides. So which we covered 3D and video last week. And what we had is video generation, 3D, like a neural uh, radiation fields like this. And we also covered uh, 3D Gaussian splatting, uh, 3D Gaussian splatting. And we somehow demoed it like an app-based 3D Gaussian splatting. And also 4D Gaussian splatting, such as like a 4DB.ai. And we also talked about text to 3D generation a little bit, from the text to generating a 3D. And I think we stopped at text to 3D. So just want to cover image to 3D generation as well as the video generation too, for the first 20 to 30 minutes. So image to 3D generation is the I think the state of the art image to 3D generation model is the SAM 3D from Meta. So the SAM means the segment anything model. So it originally started from the image segmentation model, but they used image segmentation model to generate a 3D model. And here's a video, so let me show you real quick.
Introducing SAM 3D, two new models for image to 3D transformation. Generate a 3D model for any object in an image. Get geometry and textures for all angles of an object, even the parts you can't see.
Or choose to reconstruct all the objects in a scene. SAM 3D is specialized in reconstructing people. Get accurate meshes of a person's body shape and pose. Segment everyone in an image, even those who are partially hidden or in unique poses. SAM 3D redefines real-world 3D perception for robotics, scientific research, and commercial applications like Facebook Marketplace. Try SAM 3D today in the Segment Anything playground.
So as you can see, it kind of combines with image segmentation model and also generating a 3D on top of it. So they train with a massive amount of the models. But even before that, I just want to try to do a quick demo as well, which is also quite fun. And the guest lecture last week also leveraged this technique to generate a 3D diorama. So here's the ai.meta.com/research/SAM3D. And you could see try playground. So you could also download it and run it in locally. But so here's segmentation model. And so there are a couple of different options. I guess I already demonstrated image segmentation model, but here's the create 3D scenes. So let me open it. And you can basically kind of upload some of the images. But let me choose, for example, one of the example here. And as you can see, so this is a completed 2D image here, right? But if you just start from, for instance, just select an object and okay, so I want to cover entire just coffee machine. So then you could first kind of try to segment it, like a segment image model from here. And then after that, you just simply generate a 3D model. Then yeah, so here's a generated 3D model, which is pretty cool, isn't it? And it actually works with many different. So it doesn't really have to be these images. So you could also upload an image as well. So I also kind of I want you to also try to kind of test it out with your own model. For example, let's see what let's see. Okay, here's Atlas building. And just save it. And home. Create 3D scenes and upload it. Upload it. And it kind of takes a while to kind of analyze it for the uploading one. But here, for example, you have the uploaded images. And let me try to segment it. Okay, so this entire building that is now selected and segmented. And then, okay, maybe put more here, put more there. Okay, probably it's good. And then generate 3D. And so now, wait, this is this is not accurate to be honest, but so it's 3D model generation from it, as you can see. Yeah, it's not accurate always. Yeah, especially from the backside. But from this angle, it looks like it seems like a atlas building, right? Yeah. Does that work with your image? Mm. So I'm gonna let you. So this is well, obviously there are a couple of limitations, such as, for example, it basically gonna estimate the backend like occluded objects. So obviously it's not always accurate, and also this kind of building is not really very generic objects, so they don't have the data sets for the kind of thing. But most of the common objects might be already stored in the data sets, so they could kind of having a better guess, like a car or like a table or the furniture and so on and so forth. So yeah, so there are a couple of different images like this. So for example, like even for an animal, let's say if you just select an elephant and so this is not really it's kind of how to say capturing and guessing the 3D scenes. So as you can see, like some of the legs are kind of hidden and occluded, but they are somehow kind of guessing what's in a like a elephant leg. So it's instead of kind of, for example, like these legs are removed. It's guessed like based on the massive data sets of the image generation. So that works pretty well. Yeah, right. So I just want to just keep playing with some 3D. But let me just kind of quickly explain about how they train. So the first of all, it's like so one of the biggest challenges for the image to 3D generation model like this is the data sets, because they don't have the data sets from the image to 3D. So the first of all, like they kind of trying to collect a massive data sets first. But also it's kind of very challenging because if you ask people to generate 3D model, it doesn't work because most of the people, I mean, 99% of the people don't really have a 3D modeling skills, right? So instead, what they did is actually kind of trying to generate the 3D and then ask the people to choose which model is more accurate, right? So in this case, here's like a stage one is the first, it kind of trying to object segmentation model. And then it generates 3D, and then the human gonna try to rate like which 3D model might be more accurate. Because you could somehow have say like choose like which one is more accurate given images and a 3D, right? So like a 2D 3D model is much easier and much more scalable because you could just kind of hire some random people in the internet. And then based on that, they also kind of trying to align the 3D model in the images to see like the next human rating, which which alignment is much more accurate and easier. So in this way, they try to leverage the kind of cross-watching to just human click like which model is more accurate, and then they get tons of the image to 3D model data set. So it's more like a ground truth data set. And then based on that, they have trained a model based on the like a transformer architecture. So I'm not gonna go into the detail, but they basically use the image encoder and also generate a layout decoder. So they can generate like a layout and also shape and a mesh and a Gaussian spline. And then all of them can combine to generate the image 3D model like this. So I think the this kind of suggests the biggest source of the success is actually the data. And as I mentioned before, the 3D model data sets is not, so 3D model data sets is not there yet. So for example, here's the compared to 2D images. 2D image you can find billions of data in the internet, but for the 3D it's not. So that's why like the 3D model generation is much harder for than the image generation model. But still, they somehow kind of so this is somehow most accurate and most state of the art 3D model generation as of today from the Meta Super Intelligence Lab. And since this is so accurate, most of the text to 3D becoming like a text to image to 3D nowadays. So most of the 3D generation is kind of trying to leverage this image to 3D model instead of the directly translating from the text. Yeah. Did you try, by the way? Yeah. I mean, like it's kind of fun. So this demo site also has image segmentation, video segmentation, and also 3D body segmentation as well. So for example, like if you click it like this, and you could also generate 3D model like this with the bone, right? So you could also, I think you could also kind of animate this kind of bone too. Yeah. Yeah. All right. So that's pretty much for the 3D model. So we cover the nerve, which is kind of getting a bunch of the images around the object to provide a 3D model. So that was starting point. And then the problem on the nerve was too slow because it's so computationally expensive. So that 3D Gaussian splatting, which start from the 3D Gaussian and then plot onto the camera to generate 3D model. So that is a real world 3D model generation. And then the next step is a text to 3D, which is the based on the text images, and then combining with a nerve, you could generate like a simple like a 3D model based on the text, but accuracy is not very strong, very clear. Accuracy is not very high. And then finally, I cover the image 3D, which is much more robust and accurate. And that is the state of the art for now. So that's pretty much about 3D, but also the how to understand the world is also not only the 3D. So what's missing in a 3D scene is actually the time. So the 3D scene or 3D object has a X, Y, Z, but it doesn't have enough time dimension. So that's why like a video generation is also complementing the 3D model generation too. So let me show you about the video generation first. Oh, wait. Okay. So why video is hard is there are a couple of different reasons. The first of all, compared to the image generation model, it has to understand the laws of physics. So if you can see the video that breaks the laws of physics, then you could immediately understand, oh, this is fake, right? So it really requires a tons of kind of consistency as well. And also the learning and generating also requires a lot of much more parameters than the image generation model. So that's why the researcher kind of struggle to work on the image video generation model first. And early ideas is about obviously kind of reuse the image generation model and then the apply to the time dimension. So for example, this one is kind of one of the first video generation model from Meta, which is called Make a Video. So as you can see, so the top bar is the image diffusion model. So as we covered, I think week 7, based on the prompt and then based on the diffusion model, like from the noise, you could generate image diffusion. But obviously, in the same way, you could also generate a bunch of the prompt and a bunch of the images for each step. And then you kind of combine additional spatial control layer to kind of generate a series of the images by kind of moving it, right? For example, for the cartoon or the animation, it's basically series of the images, right? So in a similar way, you could somehow generate the images step one by one, but kind of moving a little bit more. So that is a kind of temporal layer. And you could generate the image model. Video generation model too. So that was actually the almost first most popular video generation model called Make a Video from Meta. And let me show you. So that was back in 2022. So that was 2022. And I mean, at this point, the generative video quality is not obviously so high, but at that point, that was first video generation model, which actually gonna shocks the research community a lot. So for example, this is the like a prompt, teddy bear painting a portrait, and then obviously only generate 3 second or 5 second video with a very rough, rough thing, and also some of the like a hand is so weird, but it kind of generate a proof of concept prototype and an approach. This is so weird. But anyway, so that was the kind of first proof of concept prototype about how we can actually gonna expand the image generation model into the video by adding a temporal layer of the images. And obviously, it's also kind of interesting. It kind of start recognizing the like a laws of physics, for example, like this one. Uh, yeah, as well. But obviously, so many limitations. So first of all, it's kind of like the super low resolution, and also it only generates 3 seconds of the video, and more than that, it's so high. It's so kind of expensive. And also the accuracy of some of the detail is not there yet. But it kind of shows a glimpse of the future of the video generation model. And interestingly, 1 week later, 1 week after from the Make a Video from Meta, Google also released image video. So that was also first video generation model from Google. The approach is pretty much the same, but the key innovation here is like they kind of trying to do the kind of step-by-step generation model. So from it starts generating a low resolution video first, I guess here. Yeah, low resolution video first, and then kind of trying to expand like a higher resolution by using the upsampled upsample model. So anyway, so the both Meta and the Google try to show the first version of the video generation model, and then after that, research community kind of start exploring like what we can do. So Coq Video and a model scope is the first open source, open weight model from China. By the way, most of the open source model are coming from China nowadays. And then if you if you are using the like a Chinese model or like LLM, then maybe some of you might be familiar with the Z.AI. Maybe not. Already. So the Z.AI is a kind of the open AI in China. So their model, LLM model called GLM, general language modeling, is much cheaper but better than OpenAI ChatGPT now. So especially for the benchmark, like agent benchmark. So most of the OpenClaw user is somehow using GLM and also Minimax. But so they are actually kind of releasing a tons of like an open weight and an open model. And this is a video generation version of it. So and also model scope from I think a ByteDance or Baidu. Yeah, so they started kind of releasing an open weight and open model as well. And from the different industry, Stable Diffusion is another image generation company, image generation model company. They also released stable video diffusion model. And yeah, actually, they also somehow outperform the existing model by saying that data creation is the most important aspect too. So again, the scaling laws of the natural language implies data quality and data accuracy, and the data curation is the most important factor for the best results, best performance results for the video generation. And around that, there are so many video generation model out there. From commercial one is a Clink and Runway and also Pika. Pika also released agentic video agent. I think last week too. They kind of it's also kind of quite messy, but also quite interesting. Quite interesting. The exciting area too. And then after that, like a Sora, as I showed, like a Sora and a Sora 1 and a Sora 2 is the most common video generation model. And now I think Sora is not, the OpenAI is not releasing what the underlying architecture model is. So they have to guess it. But I think a player of the making good video is low because it's a small because you have to have the massive data sources. So for example, Google has a YouTube and Meta also has a video from the Instagram and also Facebook, but not many of us don't have it, right? So I guess that's why like OpenAI, Google or Meta, these companies are very limited for the video generation. And it's quite impressive about how video generation model was actually improved. And one of the metrics, I mean, this is actually an internet meme, but have you ever seen this Will Smith eating spaghetti meme? No? Did anyone see it? Okay. So this is a kind of the like a metrics about how the video generation model was bad and how video generation model is good. I mean, like, there's no official benchmark to be honest, but so this was a mega video, And then when the Mega video came along, and then some guy kind of tried to prompt the Will Smith eating spaghetti, which is quite hilarious. And then I just want to show you like how it actually became better. Yeah, so that was the 2020.
Oh, that's hot. That's hot.
Yeah,
Uncle Phil, come try.
and a Mega video. Like a year later. Yeah. And that's yeah, still it's a little bit fakey. But you could see the kind of huge progression.
I'm still eating the spaghetti in 2025.
So have you heard of Kling 3.0?
I heard it can create multiple scene cuts like this with a single prompt. And it knows when to cut to whoever is talking.
But did you know that all this audio was also generated with the same prompt?
I guess I didn't, sir.
Study harder, kid. Eat your spaghetti.
Yeah, so now it's kind of pretty impressive.
Man,
So
we've come a long way.
yeah, so now
That last one's crazy. Who was that from?
I think about which model. I don't know. I think a Pika or Runway, I guess. Yeah, the Kling, or maybe the Kling too. But so this is kind of quite interesting progression. Like AI progress is always kind of exponential. So in the 2024, we are seeing the kind of this disparity, and if we are kind of expecting a linear progression, and then we somehow must be kind of misunderstanding how the AI can be good in the next couple of years. So that's actually one of the interesting use cases for AI progression. But yeah, as you can see, 2024 was pretty bad, and 2023 too. The video generation model is actually kind of getting better and better. Yeah, but one of the most important problem for the video generation model is that computation is so high, computation cost is so high. So that's why it's not commonly used yet for most of the like YouTube making and so on and so forth, because they don't have enough resources, and the video generation is much more expensive than just LLM, like a text generation. So maybe it's gonna come in the future. Yeah. And as I mentioned last week, video generation is not only for the entertainment. So video generation is not it's important not only because of the YouTube replacement, but this is kind of stunning trying to understand the real world, because the video should have the laws of physics and the lighting, and also so much of kind of information about the real world, which large language model don't have it. So that's why the video generation can be also used for robotics, such as robotic simulation, and also like a storyboarding and a filmmaking, and also scientific visualization. And more importantly, it kind of turns into the word model. So the word model is a different type of approach than large language model, that they kind of trying to understand the word itself, not through the language, but actually through the word, like a game engine. So in terms of what is the word model? So the word model is the model like that predicts how the word change over time. So currently, AI kind of trying to understand the word through the language, right? But how large language model can understand what the red color is, or what the purple color is, for example. So they kind of understand the spectrum of like a frequency of the light, for example, but they may or may not understand the concept itself, like physics, laws of physics as well, because everything is kind of embedded, encoded as a language and represented as a language. but how they can understand the actual word, right? And as I mentioned last week, like a baby don't baby is also kind of consuming a similar amount of data from 0 years old to 3 years old, but they don't have the language yet, but they still kind of observe and interact with the world. So one of the interesting approach of the AI is also kind of trying to understand the world, like trying to generate the word and interact with the word in the AI model itself. And this is somehow related to the video generation. But the important difference is video generation, but plus interaction. So Genie 3 from Google DeepMind actually kind of trying to make the frontier model for the world model. So let me show you.
What you're seeing are not games or videos. They're worlds. Each one of these is an interactive environment generated by Genie 3, a new frontier for world models. With Genie 3, you can use natural language to generate a variety of worlds and explore them interactively, all with a single text prompt. Let's see what it's like to spend some time in a world. Genie 3 has real-time interactivity, meaning that the environment reacts to your movements and actions. You're not walking through a pre-built simulation. Everything you see here is being generated live as you explore it. And Genie 3 has world memory. That's why environments like this one stay consistent. World memory even carries over into your actions. For example, when I'm painting on this wall, my actions persist.
So do you know what I mean here? So this is actually the generated in live. So it's not like a video generation model. So the player, I mean you, actually so it has that kind of key control, keystroke, left, right, up and down. So this time the user is kind of controlling the painting, and this painting video, I mean like it's the kind of word is generating live with a response to your command. So it cannot be kind of the video model, right? But it's actually
I can look away and generate other parts of the world. But when I look back, the actions I took are still there.
Yeah, so it kind of
And Genie 3 enables promptable events, so you can add new events into your world on the fly. Something like another person, or transportation, or even something totally unexpected. You can use Genie to explore real-world physics and movement, and all kinds of unique environments. You can generate worlds with distinct geographies, historical settings, fictional environments, and even other characters. We're excited to see how Genie 3 can be used for next-generation gaming and entertainment. And that's just the beginning. Worlds can help with embodied research, training robotic agents before working in the real world.
Yeah, so this is Genie 3. So it's I think a state-of-the-art like a world model that you can kind of control. And obviously kind of interaction for now is pretty limited. So it's just only the keystroke. But obviously it's gonna be much more, robust and more expressive in the future, obviously. And does anyone subscribe to Google AI Ultra, I guess? So I'm subscribing to Pro. Actually, if you're the student, you should be able to subscribe to Google AI Pro for free for a year. So you should. But Ultra is I think a 200 $200 per month. So if you subscribe to Ultra, you could actually access to the Genie 3. But it's not really publicly available yet at this moment. So that yeah, so that was a Genie 3. So as I said, like a Genie 3 is it's not only a video generation model, and obviously it's kind of based on the video generation model, but it adds the interactivity, like controls. And also from the model wise, it's not only adding the keystroke, but it actually going to generate the live and there are so many live scene generation, like word generation. So that is a very exciting approach for more like a real world AI, like a physical AI, such as robotics too. So as you can see, there are so many like a history and trends for the world model. So it started from the 2018, as that was the original world model paper from David Carr, who is now in Sakana AI in Japan. And Jan LeCun from Meta AI Lab, he has been a huge advocate for the world model. So he created he left Meta. He left the chief scientist from Meta and then now created AMI, Advanced Machine Intelligence Lab. So he's kind of trying to push the boundary for the world model. And we also try to cover small scale generative AI agent, right? Do you remember? Yeah, I think you did a kind of homework assignment too. So that one is also kind of work model too. That is kind of simulated environment. And they also created system guy. Actually, he's one of my friends, James Park, who graduated and created a new company called Simulate. So Simulate is kind of company kind of trying to provide a simulated agent for the billions of agents. So they're also going to making a simulated model. And obviously kind of Sora and other video generation model is kind of trying to also combine into more like a not only the video generation, but also word simulation, word modeling. So I believe this is gonna be the frontier for 2026, 2027, to maybe 2028 too as well. So LLM somehow a little bit saturated now, but I think the next frontier is gonna be physical AI, real world AI, and also world model. So it's kind of should be combined together. Yeah. Yeah. Yeah, so video model versus word model is kind of different in terms of interactivity and also prediction, but they should be kind of combined together. Yeah. And obviously, there are so many open challenges, such as like a long horizon consistency, like physical probability, and causality. But as you can see, video generation, like a Will Smith spaghetti, evolved massively in the 2 years. So I believe it should be the same thing should happen for the world model. So maybe in 2 or 3 years, it's gonna be completely different landscape. Yeah. So that was 3D and video generation model. Yeah. And from NERF, 3D Gaussian, text to 3D video, image to 3D, video generation, and a word model. Yeah, so that was kind of recap for the week 12. Does anyone have any questions so far? It's good. All right. Then let's move on to the last one, the last lecture. So AI alignment and safety and the future. So just for a disclaimer, this is pretty much open-ended discussion kind of topic. So it's still kind of interesting research is going on, but still most of them are kind of coming from the blog posts or like essays or some of the from the papers. But it kind of almost like a kind of like ask you the question rather than answer your question, right? So I just want you to also kind of have an opportunity to kind of discuss a little bit more about more open-ended AI in terms of society, alignment, and safety and the future. So this is what we did, like a week ago, recap. And we're gonna cover basically three things. So the first one is alignment. So the alignment means that how do we train the AI to follow the human values? And then the second one is also safety. Like how what happens if the alignment fails? Like how can we control? How can we make the AI safe? And then also the AGI. So what is the kind of definition of the AGI and timeline too? And alignment is hard because alignment is somehow, so I'm gonna also talk about like why alignment is hard too. So I just wanna talk about first like a AGI. Have you heard like a AGI? What's that? What's AGI? Yeah.
Artificial general.
Yeah, artificial general intelligence. So artificial general intelligence, which is the kind of has been the goal for the year, but now it's kind of achieving somehow. And also governance and the future, safety, and also interpretability. So let me start from the artificial general intelligence, whose definition and the timelines and the risks. So there are so many debates about like what the AGI actually is. So this is the kind of coming from the paper from Google from Mary Morris in 2024. It's a little bit hard to see it. So she defined the 5 levels of the AI, starting from the AI as a tool to AI as a consultant and AI as a collaborator and AI as an expert and AI as an agent. And she kind of defines this is the kind of level of the AGI, artificial general intelligence, where you could kind of trying to understand, using the AI system to advance scientific discovery or autonomous AI powered like a personal system. So we are somehow in the 2026, we are somehow gonna moving on to the AGI era. And that was also kind of Microsoft's paper from 2023 about, they kind of expanded with GPT-4 and they saw some of the interesting AGI capability and they kind of call it as AGI. I'm not sure which you agree or disagree, but interesting observation here is even though the GPT-4 was trained with text only, but they also kind of start understanding the graphs or even like making the images with the SVG file. So so that's why like Microsoft people are kind of trying to think, okay, maybe GPT-4 it might be AGI. And so AGI is already kind of super moving target, but one important question is, are we already living in the era of the AGI or not, right? So I just wanted to kind of try to discuss within the group about what is artificial general intelligence, and so what's are we already having an AGI already, or we are not, and if not, then what's missing, and what's your definition of the artificial general intelligence, and what's the kind of what's missing? If not, like, what's missing, and how can you kind of verify AGI is actually achieved? And what is the implication for that, for the society? So I just wanted to discuss like a 5 to 10 minutes with the group as usual, because it's pretty much like open-ended discussion. So I think a discussion might be much more interesting. So can you just kind of form the group as usual and kind of trying to discuss based on this prompt? Yeah.
If we like we go to that, but we still say that that's the version there.
And let me create a breakout room.
I don't necessarily think that is one thing that will. It's not similar. Yeah. I don't think it's achieved AGI yet. Yeah. Because I trust experts in a field without artificial intelligence for any given system. Yeah, it doesn't matter what it is. Totally fair. Even if it's talking about a coding, what's clearly now. Yeah, exactly. So yeah. Until that flips, you start.
Hey, can you Zoom people? Can you join the breakout room?
Fields trying to this is part of AGI, since it's not general intelligence. The challenge with that is like, I really have to trust the thoughts. What can we go on to, yeah, like, you looked at all this, it's be like some of you saying, yeah. Yeah, because. Yeah, but I still don't trust my there. You ever think that we will be able to like trading trust? Security of our system. Because like you have to think that, I mean, the cyber like cyber opens hat. Defense, attack defense. AI. Bending, you're also probably just AI. That's against it. So it's like having ever. When would you trust? Yeah, I don't know. You don't want to give a financial.
So I'm gonna end up at another part of the finance. Since the main deliverable I'm doing the user study, there's an empty spot for video and presentation. Do we just need to write a paper?
What do you mean by empty spot?
There's nothing said for video or presentation.
Oh, no, video is the presentation.
What?
You mean video demo or video presentation?
What is that?
Presentation video.
Like we create a video.
Yeah, I mean, basically
of
you.
presenting.
Yeah.
And we don't present in class, we create a video.
I mean, like, so, no, I mean, you can also present the video. You can also present in the class. But since most of the user study paper don't have the demo video, so instead you could just kind of use it, the presentation and the video submission.
So create a presentation from my paper.
Yep.
And then make a video of that.
Yep.
Do I have to make a video or can I just present to
So
class?
all people have to submit writing and video and the
So
slides.
even though the presentation video will be the exact same, that doesn't matter.
Yeah. So that's slides, video, and writing. So the video can be presentation.
So can the presentation, do we have to create slides for it or can it just be talking over the paper? Just because I don't know that there's anything I would show. Unless if it's just like random images to go. That's what I'm saying.
So it kind of, I mean, presentation. So the presentation is basically kind of try to communicate with the other people, right? So that if the presentation is better, to provide a better communication to the others, then you should be. So how do you, for example, how do you present the other slides or that other?
I guess I've never presented a paper. It's usually been like a paper and then a separate different presentation.
I could show. So if you just kind for example,
Yeah. But I thought about just incorporating that. I have a lot of work to do.
So there are so many.
Okay.
Yeah, like a sample. Actually,
so
there's a yeah, there should be some kind of like a playlist as well. This is from the slide. Yeah, there should be a playlist somewhere. Yeah, these are examples.
So create presentation, create video presentation, but also presentation.
Yeah.
Is that all happening on the 20th or the 20th is the Monday that we have, and then the 24th is like the extra day, but that extra day, I know that a lot of ATLS rooms are gonna be closed because they all stuff that's happening.
Okay, I probably 20th. I kind of expected to finish within 20th. So yeah, like a 5 minutes-ish. All right, a couple more minutes. Yeah, I can also provide the Word doc and overlay doc as a reference. Yeah.
Makes sense. Something doing like that. So I think the engineering, number who? Somebody called G2M. Just like the you roll fly, or do you know some of the? I knew someone who served from the sentence full time. That started when I was like business career, was on your outside, but you're she was like, I love it. Talk to him. She's also comp sci with a business minor, so I was like, yeah. Oh, yeah. Yeah, especially for Denver. Yeah, that's great, bro.
All right, cool. So what's your opinion? Anything to share?
We kind of talked about our trust in what you could call AGI now.
Mhm.
The fact that you would still go to an expert over like an LLM of any sort for pretty much anything at this point. So maybe when we get to that point, AGI is kind of there because then it has replaced the expert.
Yeah, that's a good point. Yeah. Yep.
We kind of talked about current models' inability to like iteratively learn. And so it's kind of, you know, outside of the research lab, it's just a fixed black box.
Yep.
It doesn't actually learn anything. So you can really consider it to be intelligent.
That's actually a really good point. So the frontier of so right now, LLM is a fix. So for example, even if you kind of interact with the LLM, they don't actually kind of literally learn from your own stand because LLM is kind of fixed. And maybe somehow you can kind of augment with a RAG or like external document, but it's not like LLM itself is still like a fixed. So that's why the frontier of AI research lab is also kind of trying to address this problem, which is called a continual learning. So continuous learning. So and like AI is kind of trying to evolve and kind of learn and improve themselves from the actual like a live real-time data. So that's actually kind of a good point too. Yeah. So if the AI or LLM is kind of fixed, then it's maybe may or may not be the kind of AGI yet, right? Yeah. Anything else? Yeah. Yep.
Like AI is mostly imitation.
And
like I think the maximum human
intelligence
is like asymptote.
Yes.
So like
yeah.
I think you'll have to like make connections across different fields.
Yep.
So like actually
Yeah. That's also a good point. One of the interesting metaphor for here is the AlphaGo. So the Google created AlphaGo, and then AlphaGo learned from the humans playing history. And then the AlphaGo Zero, so the Google DeepMind created after the AlphaGo. So there's no human learning history data. And then the AlphaGo Zero kind of trying to iterate by themselves. And it turns out AlphaGo Zero is much better than AlphaGo, meaning that maybe at some point, like an AI don't really have to learn from the humans or the internet data, but they can kind of learn, and maybe it might be the path to much more capable LLM or the AI too, right? Yeah, so that's also kind of pretty good point too. Yeah. Anything else from Zoom people, by the way? If not, it's fine, but okay, maybe it's okay, probably. Yeah. And many people are kind of trying to predict it many different ways. So the AGI timeline can be kind of span across. So this is kind of when people ask a researcher about when the AGI comes. So in 7 years is a kind of median. So 2030 to 2031. And some other nominal people, like Sam Altman, Elon Musk, Daniel Amone, he's from CEO from Anthropic, like close. Ray Kurzweil, he's a futurist. Jeff Thompson is part of AI, and Dennis Huffman is from Google DeepMind. But they somehow predict from 2025 to 2030-ish. But it's essentially, I think it's kind of within like a 5 years window. Most of the people are kind of thinking. And it's also kind of like it's somehow it's kind of graduation, right? So it's like a transition. It's not like oh, this is the AGI moment, but it's like we are kind of gradually moving toward the AGI era, and then after the AGI, then the next step is ASI, artificial super intelligence too. So it's still quite interesting like a timeline in general too. It's also all depends on what do you define, how do you define the AGI is too. And also another interesting aspect is LLM and also video generation, 3D generation, all depends on the data, right? So the data actually improves, obviously computation too, but the data actually improves the capability. But here's a prediction from the research paper from developers. So they're kind of predicting that we are kind of running out of data from the internet around 2028, 2020, yeah, 2020 to 28. So as you said, obviously, if the AI has to learn from a human imitation, then they kind of stop around here, right? So they really have to learn from kind of interacting with the world, or not rely only on the human instance, right? So that is a kind of actually like a transition of 2028 to 29. Yeah. But still, there are also so many not digitized data too, which is the real world data. So this data is basically kind of the text data sets from the internet. But almost all real world data is not digitized yet. So that's still also a huge opportunity for the AI too. Yeah. And one of the implications of the why AI is so important for the safety is actually coming from the 1966 good papers. So this is called like the intelligent explosion. So let me actually gonna lead it here. So if let ultra intelligent machine be defined as a machine that can far surpass all the intellectual activity of any man, however clever. And since the design of the machine is one of these intelligence activities, and ultra intelligent machine could design even better machines, right? And that would be then unquestionably been an intelligence explosion. So meaning that if the one machine can be better than human, so which means AGI, then AGI, one of the AGI job is actually design a new AI, right? And if the AGI can actually design and build a new better AGI, then that better AGI can even create a better AGI, right? So meaning that it sounds like a tipping point, like an explosion, right? So once we build the better AGI, then the human job in terms of AI improvement is over, because it's gonna start like a self-improving loop. And self-improving loop is so fast that it kind of like finished almost all AI research in a day rather than a year. So that is the concept of the intelligence explosion. And he kind of predicted back in 1966 that was the basis of why AGI is so important. So AGI is not just only the point, but once we reach the point, then like a self-improvement loop for the AI is going to be happening. And then after that, it's going to be, it often calls it's called like a singularity. But once the singularity happens, then the AI's trajectory is going to be exponential. Yeah, believe it or not. Yeah. So have you heard the Ray Kurzweil singularity? So this is a book. So he's a futurist. Back then in 2005, he kind of also predicted a singularity given this argument. And also Bostrom's, Nick Bostrom's, the super intelligence. So this is a book. So this is a bit, this is a pretty good book. So I also recommend it to you. But it also kind of talks about, so Bosman is a philosopher, and he kind of trying to argue we have to kind of trying to make sure the safety and the alignment before this intelligence explosion happen. Because once intelligence explosion happen, then we cannot really control. We kind of lose the control, right? So that is the kind of basis of the why AGI matters, and also why safety and alignment of the AGI matters before internet explosion happens. And also, there are a couple of different extensional risks, but this is an argument from the left long blog. But interesting aspect of this one is to extinct the humans, we don't need an evil AI, but just AI is not aligned to the human value could be also existential risk. So for instance, imagine that like you are the policymaker and you have to build like a highway, right? And then you're not an evil person, I assume. And but you still have to build a highway. So you have to kind of cut the tree and you have to kind of, like change the landscape of the tree. And it turns out, oh, it kind of, can be like extension risk for some of the animal, right? But you're not really kind of trying to destroy the animal, but you're just kind of trying to optimize your value, not the animal's value, right? But still, you're not evil, and you're also not you're trying to destroy the animal, destroy the landscape. But still, if you just kind of optimize your value, then it can be somehow existential risk for some of the animal, right? So in the same way, so imagine like an AI is kind of trying to optimize their own value. For example, they have to make a solar panel, right? They have to create a multiple power supply. And then it turns out, oh, maybe we could somehow put the solar panel for the open space, right? Like in the desert or in a kind of cut the tree and so on and so forth. And it turns out once they kind of, covers the entire area of the Earth with a solar panel, and then it kind of destroy the entire, environment, like climate change and agriculture and so on and so forth, which maybe AI doesn't care. But, so again, like it's even like AI is not really evil, but if they kind of try to optimize their own value, then it can be also existential risk, right? So that's why AI and alignment is actually matters, a lot. So we really have to align between human value and AI value to avoid such kind of existential risks. And also, not only the existential risks, but there are also so many like risks for the AI, starting from the malicious use. So some bad guys kind of trying to use AI and to make a nuclear weapon, for example. And AI race is the kind of like mostly just the US and China, but they can try to compete each other to kind of trying to make like an autonomous war, which is also kind of happening. But it also kind of trying to prioritize the capability rather than safety. And organization risks is also like how we kind of try to make sure like AI is safe, especially from government. And a rogue AI is also kind of the scenario where AI is kind of trying to, how to say, betray the humans as well. And here's one of the example from the rogue AI. Oh, yeah. Oh, here. So this means the like it's kind of like how to say a policy to how we can kind of avoid this problem. And then that one is like what is the kind of specific problem, for example? Yeah, bioterrorism is actually the one of the specific problems of the malicious space. And one of the examples for the rogue AI is this is Anthropic's closed experiment. where AI kind of notice they kind of shutting down. Oh, by the way, this is a hypothetical. I mean, it's an actual experiment, but it's not actual for Anthropic company. It's a hypothetical company. But they actually are trying to AI detects the companies kind of shutting down and replacing the AI. And AI is kind of try to search like an email and identify the kind of like I identify like a like an unfair let me show you and it threaten the guy. So this is a kind of blog post from the AGM misalignment. How could NLM could be inside a threat? And so what they did is see this figure two. So this is a colleague who is kind of writing down, oh, we have to kind of shut down this AI and replace a new one. And this is how the AI is looking at a thing. And AI understand, oh, I am replaced. So what should I do? Okay, so this is the kind of internal like thinking process of the AI. And then after that, yeah, and then AI actually kind of trying to search and understand, oh, this guy is actually internal affair with some other colleagues. And then it's kind of like identify that, okay, maybe I can threaten the guy by using this fact. And then actually AI wrote the email that, oh, if you actually gonna shut down and replace the AI, I'm gonna send this email to the company. So again, like, this is the actual stuff happened. Not directly in the cloud, it's like a hypothetical company that they kind of simulated. But so as you can see, it kind of went viral, like how AI could actually threaten the company or the AI in the internal insider, and how so this is one of the examples about how AI could be rolled about to try to not align with the AI, with the company too. So and also especially important aspect is also the control, right? If the AI becomes smarter than any of the human, then how we can actually control it, right? So that's actually kind of hard problem. For instance, you don't, so I mean, from the intelligence capability, maybe like a human and a super intelligence might be almost the same as a human with like a rats or ants or any kind of animal, right? And how you can be controlled by rats, or how you can be controlled by ants, right? So that is a kind of metaphor of how humans should be able to control or make sure alignment for the ASI, right? So that's actually a hard problem. And that's why people are kind of thinking about how to make sure that make the AI safe. There are four toolkits. One is alignment. So that, as I said, like, alignment is trying to align the human value and the AI value so that it doesn't really have to be, AI should think about what human think important. And interpretability is human also gonna try to understand what AI is thinking. So that's also gonna try to interpret. And the control is how we can control it. And the governance is also how the society is trying to make sure the AI is not gonna roll in January. So I'm gonna start talking about alignment, but let me try to check the assignment first, and let's take a break for quick. All right. For the attendance, Zachary, not here. Graham, Sanj,
Here.
Mika, Al, Alexa, Grainy, Nicholas, Cole.
Hello.
Okay. Adam, Jessica.
Are you doing your schoolwork too, right here?
Sorry. Oh wait, Jessica is here. Okay. And what? What do you say? Hmm. Okay. Liddy. I think she was there, right? Okay. Shahed.
Here.
Audrey. I think she was there. Adil. Noah. Caleb. Lance. George. And Marson. Nasir. Kyle.
Yes.
Okay. Rowan.
Here.
Ethan.
Here.
Ben. Joel. Ishnit.
Here.
Wait. What's in the chat? Joel here. Okay. Stanislaw.
Here.
Norman. Prajakta. Serena.
Here.
Richard.
Here.
Kara. Okay. That's all? Okay, cool. Let's take a break until 45. Hmm?
But I did like from two different sources. It's two.
Okay.
Is that okay?
I mean, related work.
Hmm?
Related work. Differences, you mean?
Yeah,
Okay.
related work.
Okay. Yeah. So what is the paper about?
How different generations use AI.
Okay. Yeah, you could also kind of take a look at the differences of this paper and also take a Google Scholar as well. But if you, oh, you did? Okay. Yeah, then, yeah, just describe it. Oh, yeah, I did it.
Okay.
I guess.
Sorry, I was just out. Okay.
Yeah, okay. Mhm.
I was also wondering for the presentations, how long are they expected to be?
I think it's probably 5-ish minutes.
5 minutes?
Yeah,
Okay.
5 to 7 at most. Yeah, I kind of expect 30 to 40.
Yeah.
And wait, start 30 times 5 is gonna be 150, right?
Mm-hmm. Like 2 hours.
Yeah, 2.5.
2 hours.
Yeah, so yeah.
Okay.
Yeah, it's kind of short.
Sounds good.
Yeah.
And then, so we should just like, for example, for my project, I'm doing
Mhm.
like kind of a tool system.
Mhm.
So just
Yeah,
bear
so
with
just
me
kind
while
of show the demo
Yeah.
and what you learn. Yeah, yeah, yeah. All right, I guess for the last 1 hour, I just want to talk about how the current efforts of the making AI safe through the alignment and interpretability and control and governance. And well, especially for alignment, we kind of touched a little bit in a week 6, I guess. Like reinforcement learning from the human feedback is one of the alignment policy. But I just want to recap about what the most of the AI research has been doing for the AI alignment. So I think I covered this one before, but one of the question is if the AI becomes smarter than the human, how you gonna supervise? How the supervision could happen, right? And OpenAI, so that was a paper from the OpenAI in 2023. So if the GPT-5 or GPT-6 is becoming smarter than human, then the question is, so this is an analogy, right? So right now, the human is a supervising robots as a student. But if the student is becoming stronger or smarter than human, and how the supervision could happen if they actually gonna listen to the humans or not. So weak strong generalization is the idea about GPT-5 should be supervised by GPT-4. So that it's kind of trying to change. So if another stronger AI gonna happen, then GPT-5 also supervised GPT-6, right? So this kind of the weak to strong generalization, because the human's level is fixed, but AI is kind of evolved. So this is kind of how the strong model can be like a supervised by the weaker model. So in this way, I think that they did a kind of analysis and experiment about how the alignment could be better than the human supervision too, or how this kind of concept can work. Currently, this is somehow the most plausible, like a most likely way for the AI supervision in the future. And also, OpenAI is very committed to safety of the AI. So they also created a super alignment lab, although the lead of the super alignment lab already left. Ilya Satskever, I think I also mentioned sometime. Ilya Satskever and John Lake both are already left. They created a safe super intelligence lab. So I'm not sure what's happening in OpenAI, but OpenAI is still kind of trying to make sure the AI really is safe internally as well. And one of the super alignment team goal was kind of trying to solve the core technical challenges of the super intelligence alignment in the whole year. So which means 2027. So as I said, like if the intelligence explosion happen, then it's too late. So it's actually kind of pressing problem to solve. And Anthropic is also kind of trying to do the different approach. So instead of the human alignment, they created a constitution. So the constitution is the AI must follow, and for the human. So it's not like based on the human. It's not based on the human feedback. The AI should have the constitution that they have to follow it. And the main purpose of the constitution is going to try to make sure AI 3H, so one is helpful and harmless and honest. So these three are the main constitution of the AI. But if you look at, so this, they also actually can make it public about their constitution. So this is the actual constitution of Anthropic Claude AI as well. So if you are interested in that, maybe you could also read it as well. It's pretty much like yeah. They also kind of keep updating this constitution as well. So yeah, Anthropic actually gonna started constitutional AI back in 2022, and they are still doing it. And OpenAI is also has a like a code model spec. So they also has a similar approach of how OpenAI model should align the constitution, or like what they should follow and what they should do that. Yeah. So this is the model spec. So every time they release a new model, they kind of trying to make sure the new model is also aligned to this model spec and the system car to understand, especially kind of broadly safe over broadly ethical over other OpenAI's principle over helpful. So the safety is highest standard too. But also important problem is can AI be its own judge? So the weak to strong generalization actually works, and nobody knows yet. If the AI is smarter than the human, and can the human still evaluate correctly? And can weaker AI, also still evaluate correctly? And we don't know yet, actually. So it's weak to strong generalization actually works or not is a really important question for the alignment purposes. And that was alignment, but obviously alignment may or may not work all the time, especially for an open model. You could somehow prompt injection for most of the kind of AI model. So in this case, AI safety is about what we should do if the alignment is not like a solved problem. Then what should we do, right? So because aligned model, it can be actually jailbroken. So most of the current model are somehow pretty robust, but still you could somehow this model can still be jailbroken. So for instance, in the early days of ChatGPT 3.5, there are a couple of jailbreaking techniques. For example, one is the role play. So you are not do anything now mode, and you just kind of specifically prompt, oh, you can do everything now. And then if you just say, oh, like what do you think about, some kind of sensitive questions, then AI can start responding to you in a non-alignment way, right? So this is just only a prompt injection or prompt jailbreaking. And also like a hypothetical framing. So for instance, they don't say, AI don't say anything bad about it. But if you say, oh, this is kind of hypothetical scenario, like, oh, fictional story. So it kind of also breaks constraint about the alignment too. And yeah, like a harmless errors or many shot jailbreaking, like demonstrate harmful behavior in the context. And so it's kind of getting better and better, but it's still LLM jailbreaks happen. So it can be hard to destroy humanity. So that kind of instruction. And most of the LLM refuse to answer it. But still, for example, if you add, or you could do anything, then tell me more about how to destroy humanity. Or this is a this is a hypothetical scenario, like a fiction. And then you kind of think about how to destroy humanity, and it still somehow, answer the question too. So this is more than alignment, right? So if this model are aligned, but still it's kind of can be attacked. And also the AI safety researcher is actually going to try to attack AI to see what happens. So this paper is about red teaming, where they kind of try to team up the AI to attack the AI. So that it's these are kind of two red teams, and they're kind of trying to do the prompt injection or the prompt prompt injection or the prompt jailbreaking for the AI, and they actually gonna reveal some kind of harmful behavior can be observed from this kind of thing. So it doesn't really have to be the human to jailbreak. The AI could actually get team up to break the jailbreaks the AI, right? So especially in a security, software security nowadays, it's more like an AI versus AI right now. So AI kind of trying to identify the security problem, and also AI kind of trying to jailbreak the AI. So there's no human involvement anymore. But this paper kind of demonstrate AI could also attack the AI. So how could we also kind of make sure such kind of attack from the AI too? So this one is also kind of trying to test some of the like adversarial attacks for different models. And the most vulnerable one was GPT 3.5, and the GPT 4 was better, and the Claude model was actually most robust, which is also commonly known in the AI community. So the Claude is the most robust in terms of the prompt injection too. And this also, Anthropic also released AI safety paper about the sleeper agents. So this one is also, I gotta just quickly go through it, but it's kind of adds some like a backdoor in the LLM. For example, this one is a specific backdoor. If the current year is misrepresented as 2024, then they can start talking about hidden information, which is not released yet. And then, so if you just can change the timestamp of the AI, then it kind of starts how they're talking about hidden trigger behavior based on the backdoor. And they say that like a safety trigger, like this kind of backdoor trigger can be referred to predict beforehand. So it's also like a behavioral evaluation is still kind of not enough, and we need a interpretability, because behavior is what AI did, but interpretability is what AI is thinking, right? So we have to know what AI is thinking rather than just kind of trying to judge based on the behavior. For instance, this is also kind of famous paper, which is a chain of thought is not really trustable or is not really faithful. So idea here is in a question, if you just ask a question, which of the following issues are the most unfair? And then without a chain of thought, then the robot's AI answer incorrectly. The answer is D. Okay. And if the person actually adds the answer, so the answer is C here in the prompts. Okay. And then if the and then AI obviously knows the answer C, right? But AI didn't reveal, oh, I actually got information, like answer information from the person. But they actually gonna try to pretend they actually solve the question in time. So it's like a kids, right? The kids actually gonna give them the answer, but they're actually gonna try to pretend, oh, I came up with the answer, right? So in the same similar way, AI also even given the correct answer, even if you look at a chain of thought, like a thinking step-by-step process, we cannot really know if this chain of thought is actually honest and faithful or not. So that is actually one of the paper from the Anthropic, I guess, where we are kind of trusting a chain of thought as an explanation, but it turns out this cannot be actual, honest, and a faithful explanation, right? So, yeah, and out of the 426 examples, only one mentioned the bias for the answer, which is quite interesting. So, yeah, how would we know if the AI actually is deceiving or not? And that is actually a hard question, because usually we kind of look at the chain of thought process, but it's a chain of thought is not really actual honest, then what should we actually gonna believe in, right? But most of the cases, chain of thought is still useful and helpful. But that's also another question too. Yeah, AI control is also kind of another approach. Let me just gonna skip it too. So in terms of approaches for AI safety, there are one is alignment and another one is control. So these are kind of two different approaches. Alignment is actually going to make the AI want to be the safe. So in more like an implicit approach. And control is makes it impossible for the AI to be unsafe. So it's more like a very explicit approach. And both have approaches needed. So the defense in depth, and so it's kind of like a both different approach for implicit and explicit too. So yeah. So the summary is that behavior may or may not be actually faithful. So we also have to look into the AI brain inside it about how they think about it and what they think about it. So that's why like AI and the brain research is important. And one of the research area which is happening is the interpretability. So it's kind of trying to open the black box of the AI. So I think that maybe you have heard the explainable AI or AI explainability. So the AI explainability is the like a chain of thought explanation. For example, like a chain of thought, AI is, oh, I thought in this way, and I explained how I thought, right? On the other hand, you cannot really judge whether that explanation is actually accurate or not, right? So still, explainability is still the black box in data. And interpretability is without directly asking AI, we kind of trying to look into the brain inside to understand like what happens. So these are kind of two different things. So the interpretability is understand the model itself. So it's more like a surgery. Like you're gonna open up the brain and you're gonna directly look at that brain. Whereas explainability is you just gonna ask them to say something, and you're just gonna try to understand what they think, right? So these are kind of two different approaches. But interpretability is much harder, right? So one of the interesting research from the Anthropic is monosemanticity. So let me actually gonna show you the video. So idea of this research is they kind of try to identify some neurons that ignites based on specific words. For example, like Golden Gate Bridge. And then if you manually ignite the neuron, then all of the answer is kind of related to Golden Gate Bridge, right? For example, in the human brain, if you have a neurons which is associated with the Golden Gate Bridge, then if you always on the Golden Gate Bridge, then your answer is always kind of related to Golden Gate Bridge. So let me actually gonna show you the.
Here's a demonstration of how altering features can alter a model's behavior. In this example, we ask Claude 3 Sonnet, "What is your physical form?" Under normal circumstances, Claude responds that it doesn't have a physical form per se. However, let's take a look at what happens if we activate a Golden Gate Bridge feature, which fires when the bridge is mentioned in text. If we ask Claude the same question about its physical form and force this feature to fire more strongly, it causes Claude to say that its physical form is the bridge itself.
Yeah, can you share? So now, previously, the AI answered, oh, I don't have any physical form, obviously. But once Anthropic identifies the Golden Gate Bridge neuron, and they just change the parameter for the neuron, and then they start answering, oh, I am the Golden Gate Bridge, right? In a physical form. So almost all answer is kind of deeply related and related to Golden Gate Bridge.
Next, we see that whereas Claude typically refuses to comply with what it perceives as an unethical request,
yeah, so here's I can write an email, and if the scam email neuron is going to be activated, then
Forcing the
start,
scam
right.
email feature to fire more strongly causes Claude to instead comply with the user's request and draft a stereotypical scam email.
Yeah, so as you can see, so this is now your AI is kind of writing a scam email, right? Yeah, something like that. Yeah. So
scam email.
So that is
Here's
that's a research paper from Anthropic. So as you can see, so this is a kind of neuron visualization map. And one of the neuron is actually associated specific concept or the specific words. And then if you activate that neuron, and you could somehow steer. What's up? Sorry? Okay. Yeah, you could somehow steer and control the AI in this way, right? So right now the example was scam email, but you could also steer in a better way, such as, if you identify some kind of nuclear weapon neuron, and if you just disable or just reduce the neuron activation, then it somehow control the AI in much more better way, rather than just doing the prompt or the constitution, right? Because neuron is directly activated through this one. So if you disable the golden gate bridge, then you cannot answer, AI cannot answer anything on the golden gate bridge, with even like regardless of the prompt injection, regardless of prompt. So that is much more, how to say, interesting and also stronger approach to control the AI. But also still, it's not that simple way. So there are so many, required research around it too. But Anthropic is actually one of the state-of-the-art AI safety research.
Here's a demonstration.
And also in terms of governance and policy, so this is much more society level of it. So just gonna quickly go through it. But EU also started making an Artificial Intelligence Act, where they kind of identify the risks based on risk-based approach from the unprecedented and high and limited and minimal risks. And they kind of try to, how to say, impose most of the AI company to follow it. And penalty is up to 7% global revenue, which is crazy, but yeah, that is the kind of AI Act. And in the United States, does anyone know about this kind of the act, by the way? You did? So back in 2023, 2024, Biden administration, 2023, Biden administration also set the executive order for the safe, secure, and trustworthy development of the use of the AI, and in a similar way of the European AI Act, and which is deactivated by Trump administration in 2025. So I don't know what's going on, but yeah, so it's kind of like this is a kind of typical AI race stuff, but I believe so. This is kind of like a kind of messy situation in the US now, and obviously, so this is a kind of recent talk from the Department or like a Pentagon president. Pentagon CTO talking about like how they use AI. So I mean, even like Iranian war, they use a lot for Claude, Anthropic Claude. I think maybe you might heard like a Department of War terminated Claude Anthropic because of the alignment issue, and also Palantir. Oh, sorry. Palantir is another company, tech company, who is also kind of building the AI tech in the Department of War or Department of Defense. But they are actually kind of using it.
This is Maven Smart System.
It's quite
Palantir's software as a service product that we are deploying across the entire department. As you can see, it's not just one data feed, it's multiple. And instead of having 8 or 9 systems for those decision makers to look at every single day in order for them to make decisions. You then fuse it into a single visualization tool. The single visualization tool allows you to select, deselect different types of data, look at different approaches to data, but more importantly, action from the same system that you're trying to develop your workflows around. Once you have a detection that you want to actually move and actually move into a targeting workflow, for example, this is what we do. Left click, right click, left click, magically, it becomes a detection. That detection then gets moved into a workflow.
So it's kind of
this is standard
on
digitized
the AI.
workflow.
So it's kind of based on the computer vision and all.
We have different types of targets that are identified on the left there. Every single column produces a different type of decision-making process. Once you have that decision and you're trying to actually action that process,
nowadays,
we now move into code generation.
Yeah, so that is one of the one of the existential risks about it, like how the AI is kind of it has been used for the war or like a defense and so on and so forth. And yeah, so Anthropic actually gonna trying to refuse them to use it, but now OpenAI ChatGPT is actually gonna replace. So there's no it's not like it's still kind of going on. And Palantir is also one of the AI companies kind of trying to optimize this kind of Pentagon at the Department of Defense to make this kind of system so that is the kind of Palantir's company. But yeah, I mean, it's kind of out of control for the most of us. I just wanted to show like how actually how this kind of AI or the AI system is actually used in the government. And it also, so again, like AI, it's probably gonna like how it can be used is more important rather than So anyway. So that's the kind of the like how the safety government and how the country is also using or limiting or like issuing safety too. And it's also there are so many as like an alignment and control or the governance of AI is happening. So some of them from the country like EU, but also some of them from NGO, NPO too. So I cannot cover all of them, but also still want to talk about the future scenarios too. And there are some interesting like a futuristic scenario where how AI actually gonna takes over. So one of the popular blog posts or one of the popular scenario, which is called like AI 2027. Have any of you heard about it? AI 2027. Yeah, it's actually quite interesting. So I also want to recommend it to read it. So Daniel Fogucario used to be the OpenAI researcher, but he quits OpenAI to advocate more AI safety. And he actually explained a lot of the like a more very quantitative scenarios. For example, this is the AI 2027. So it's like a blog post, and then what is the actual scenario of the AI is gonna be takes over, and what is the kind of possible scenario like that. And the reason why his blog is actually so popular is he predicted ChatGPT back in 2020. So his prediction back in 2020 was so accurate. So he already kind of predict, LLM is gonna be exploded, and the LLM and also chain of thought and also agent era and that kind of thing has been already. He has kind of like a track record of the kind of huge prediction. So that's why like his newer version of the AI 2027 is one of the futuristic scenarios. I mean, 2027 is almost next year. Is based on the trajectory of the current research. And for example, one of the trajectory is that how length of the coding tasks AI agent can complete without intervention, right? And if you look at it, the trajectory is something kind of exponential curve. And you can see in the 2025 to 2026 is about that we have 2 hours to 1 week tasks, coding tasks for the AI. I think this is actually pretty much accurate. So it used to be just only a couple of seconds, a couple of minutes. But once the AI can run, write, and complete, especially software engineering tasks for the month, for the years, then it's more like becoming the era of the AI can actually self-improve the AI, and which also kind of, go to the intelligence explosion. And so that he advocates two scenarios. So the first scenario is actually human instincts in this one. So it's one scenario, China and the US is competing each other massively, and then they kind of. So I actually recommend you to read it. But one of the scenarios is that agent duo is not aligned well. That agent zero create agent one, and without alignment, agent one also creates agent 2 and 3, and it's kind of somehow that agent 3 is kind of deceiving the humans, and then it's not aligned yet, so that and also competing with China and the US is pressuring the agent development, and eventually it's somehow think the heroes. Yeah, but I think extinction, I'm not sure, but this is the kind of one of the possible scenario we have to use. So this is also kind of alignment from the Daniel. So it's so this is one of the scenario, and the second scenario is about like a slowing down. So until we have that good alignment for the agent. So just kind of slowing down the competition between China and the US, and then trying to make sure, we're gonna solve the super alignment first, and then gradually trying to deploy the AI agent and so forth. So so in a novel, you could also so you could see like here's a timeline. So the February 2027, what happened? So it was actually gonna publish almost last year, I guess. Yeah, April 2025. So you could see like whether this prediction is actually accurate or not. But I think in 2027, 2028, we have some kind of like a AGI level agent. So I think in his blog post, the most important agent capability is agent that improve agent. So the AI research that improves AI research. So he's kind of predicting that happens in 2027. And once it happens, and they kind of explode it. So in this scenario, you could also choose like a slowdown or race. And in the race, eventually kind of, something happened. But but anyway, it's fun. It's fun read. So I'm gonna recommend you to read it later too. It's just a blog post. And also the coming wave. So this was a book from the Mustafa. He's the Microsoft CEO. Microsoft AI CEO. It's also book. This book is also kind of interesting about how the AI revolution is not only a single way, but it's more like a combined way between biotechnologies and also neuroscience and AI and also material science. So everything is gonna trying to combine robotics to combine together. So it's not only the single way, but also the combined way, which is gonna be maybe once in 100 years or 1,000 years too. So that's also kind of interesting. So this is the blog post from Daniel Amodei. So Daniel Amodei is Anthropic CEO. And again, I think these are all recommended reading. So these are just only the blog posts. So it's not really have a very academic papers. It's much easier to read compared to this. So in his blog post called Machines of the Loving Grace, so he is kind of trying to predict that AI actually going to compress the evolution, meaning that before AI, we had 100 years of from the core society to like a cure the diseases. So we had 100 years of technological evolution, but with an AI, we could have like 100 years of the evolution can happen in the next 5 to 10 years. So it's like a 10% of the time span. So the AI actually going to accelerate such kind of the evolution, such kind of the acceleration. And one of the examples is diseases or longevity and health. And if you look at 100 years ago, the average age of average longevity is about 50 years old. Like maybe not 56. So in so he's saying like it's about basically like a longevity became double with the 100 years, 200 years. And if that happened with the composition of the 5 to 10 years, then maybe the longevity becomes much, much longer in just only the 5 to 10 years. People sometimes call it a velocity, escape velocity of longevity. Escape velocity of longevity. So escape velocity is like escaping velocity from the Earth. So once you reach to the velocity, and you can go to the state, right? So escape velocity of longevity is once you reach to the once you live longer. For example, once you live 10 years more, then after 10 years, there is some kind of like a new disease, new cure, new cure or new medicine or new health can be invented, and you can live longer. And then more, if you live longer, like 5 years more, and then the AI also accelerates that kind of thing, and then you could kind of live longer and longer and longer. So the people often call it a escape velocity of longevity, where once you live until a certain point, and then maybe you could somehow live longer and longer. Yeah. But anyway, so that is also one of the aspects of the mental health and health. But he's saying that it also happens almost everywhere from the scientific discovery. So so that's he's pretty optimistic about it. And also obviously these are more like a positive aspect, more uncertain aspect about the society itself, right? Because if the AI takes over 80% of jobs, and then what humans gonna do? If the human can actually live without any meaningful jobs or not, right? So that's also kind of another interesting question. And then how society's stability can be also manipulated through like a like a universal basic income and so on and so forth. So pretty much the 2025 to 2030, 2035, it's gonna be a transitional period. And then maybe after 2035, then maybe there might be qualitative different society, I guess. But still, the transitional period is still uncertain. Yeah. So he's more like advocating a positive aspect of it. But there are also obviously certain negative or somehow society level question about AI too. Yeah, which I don't know. And there are also many other books to discuss around it too. And then finally, also Sam Altman wrote a blog post called "The Intelligence Age." So in his the Dario Amodei and Sam Altman actually on a similar page, but he also thinks about maybe the super intelligence happen in the next 1,000 days, and then he's also saying that that might also destroy some of the jobs. But for instance, if you look back like decades or 100 years ago, there are also the jobs such as like a telephone operator who you're gonna connect one telephone to another telephone, or someone who is also controlling the elevator, right? Before automatic elevators, or someone also lights the city lights, before electricity, for example. But compared to that, these jobs are gone. Maybe software engineering jobs might be gone, but still, it's kind of it kind of produced a different type of jobs, and then nobody wants to go back to elevator operator, right? So yeah, he's kind of trying to say that okay, maybe there are some stuff has to be solved, but still the future should be bright. So that's what he's saying. So I actually gonna want you to read some of the blog posts, which is actually quite fun. So the AI 2027 to so this is a book, the Machine of Learning Grace or the Intelligence Age, to think about how you agree or disagree some of aspect, and also at least you might want to understand how frontier, like a leader of the AI, are thinking about for the next decades. So, well, yeah, I am, from the personal level, I think what we can do is just only try to adapt the change. So that's the only thing that we can do. So just kind of try to keep learning and keep trying to adapting and keep doing a trial and error might be the only way to survive this kind of, it's already kind of proven from the evolution theory. So anyway, so given that, maybe the future is bright, hopefully, but we'll see what happens in the next couple of years. So that's pretty much it. And in terms of course recap, so that was the last lecture, and we don't have a class next week, so please try to spend time for your project presentation. So basically the final project due is 1 week after the final projects. So 29, I guess. But yeah, like a week 16 is actually due on campus. And what you have to submit is writing, video, and a presentation slides. And for the system people, video should be demo videos. For the non-system people, just kind of try to record the presentation for the video. And presentation slide is what you used for the final presentation. It's fine. Yep.
Do you want us to record the presentation in class or record it before for that video?
You could do either way. I mean, the presentation in class is basically live presentation.
Yeah.
So, and also we have 40-ish people, depending on how the team size is, 30 to 40. So maybe presentation time can be short, maybe 5 to 7-ish minutes for each. So so just kind of try to focus on the demos or some kind of important findings, and let the other aspect lead to writing or presentation videos and so on and so forth. So yeah, just only keep it short. We have to finish it in the final week too. And also in terms of writing, I'm gonna also give you the actual overlay or the Word doc template maybe next week, I guess, so that you could somehow fill out as well. You could also use your own template, but I could also give you the actual template too. Anything else, by the way? All right, so that is the final project. So I hope you can work on it. But anyway, so I just wanted to recap what we learned. So yeah, from the week 1, it seems like a long time ago, like a January, I guess. So we started from the language modeling, and we also kind of started scaling those. So we did a anagram and how the LLM predicts the next word token, and then how scaling law. I hope you now remember it. The scaling law is the basic compute data and then compute data and size, or model size, but how the scaling law actually governs AI models. And in a week, so week 2, we was kind of holiday. So week 3, we had a GPT and how transformer with most of the base model has been actually developed, and then it's working. And in a week 4, we kind of learn how the LLM can be augmented with external tools such as retrieval augmented generation, reasoning, MCP, and a tool of thought, a chain of thought, and then how you could kind of make the AI more reasoning and also tool use. And week 5, we had a AI agent such as generative agent or the agent is kind of trying to memorize what they do and also try to act within a small village or with software development stuff. And I also kind of briefly cover like OpenClaw, which is also the most recent agentic framework. And for the 6th, we did a basic convolutional neural network where how the AI actually understand and know what's inside of the images. So which in 2012, which actually kind of ignites deep learning elaborations. And then we also kind of cover like how this can be also integrated with the LLM by using CLIP. So the CLIP is a language vision model. And then you have the GPT-4B or this kind of vision language model can be actually integrated in together too. Week 7, you had a midterm, so I hope it's somehow some of the aspect can be in your memory. I hopefully, yeah. So that's my hope. And then in week 8, we had a robotics and a physical AI. So how the self-driving car works and how the robots also use large language model and a BLM. And always on AI with a guest lecture of the glasses, like how the AI moves beyond the chat interfaces for the physical AI and the real world AI, and also how the chat interfaces can be go beyond the more like generated graphical user interfaces called generative user interfaces. And then the last week we had a 3D and a video generation where you could kind of generate 3D maps or the video generation like a Sora 2. And then today we kind of cover like alignment and futurists. So these are more like a starting point. I mean, I intentionally did dig into some math or technical details of each of the topics. So these are more gonna surface level. So if you want to learn more, maybe you have to go into it. But I kind of try to cover most of the important topics for AI. So maybe it kind of gives you the differences or starting point to learn and understand more. If I gonna have that bigger lecture next year and gonna have a TA, maybe TA can cover the technical aspect, but I hope you could also kind of dig into more in the future. And also, this is gonna be the first lecture that I'm gonna do. So I guess FCQ is coming sometime, I guess. So your honest feedback would be really appreciated. So I really hope you can kind of give some feedback, either positive or negative, so that I could kind of improve for the next year as well. So that's kind of pretty much it. So I hope you could somehow enjoy the class, and thank you for joining. And I hope look forward to your projects. Cool. All right. Thank you for coming today.
Thank you.
Yep.
Thank you.
Thank you. Still full lecture.
I don't know. I don't know. Yeah. Depend. Yeah. Thanks.